Hi, Amy. How are you?
Hi, sir. Yes, I'm doing well, thank you. How are you?
Good, good. So, how is winter going on?
So it's not as bad as when I last told you. It's actually getting a little bit warmer, but
Mhm.
windier as well. But
Okay,
the ice and everything has calmed down. It's not like bone chilling or anything. Yeah, so
very
it's
good.
okay. Just windy. Yeah.
Even then, take care. So,
Yes.
today, what do we begin with?
So is it all right if we could continue with our probability kind of chapter where we're just I think the last thing we covered was conditional probability.
Right.
We touched upon it, but not fully. So
We
yeah,
can
if
continue.
you
We can continue. Yeah. You can share whatever you have, and then from there we'll begin.
okay.
Correct. So, which question?
Oh, so I think we covered these ones. So did we end on question 10 last lesson?
We end on question 9. We can begin with question 10.
Oh, okay.
Can you
Yeah.
please read the question?
So, question 10. A, B, and C are three events with probability A is 0.25,
Mhm.
probability of B as 0.4, probability C as 0.45, and the probability of A and B and C is 0.1. Given that A and B are independent, B and C are independent, and A and not B and C is an empty set, part A, draw a Venn diagram to illustrate the probabilities.
Okay. Okay, so once you draw the Venn diagram, probably you can answer the other questions easily.
Yeah.
Now, tell me, we are given few things here. So out of them, we are saying A and B are independent. What does that mean to you?
So the probability of A multiply the probability of B should give the probability of A and B.
Very good. So probability of A and B is equal to probability of A times probability of B. Perfect. Similarly, B and C are independent. It means probability of B intersection probability of C is probability of B times
See.
probability of C. Correct. Now, what is the meaning of the last statement given to you as A intersection not B intersection C is an empty set? What does that mean?
Um, they have nothing in common. So you know when you draw the Venn diagram,
Mhm.
there should be no intersection between those three categories.
Okay. Okay. So we'll look into this part more
I
carefully.
think.
So one part is very clear. We know we can find probability of A intersection B, B intersection C, one, two. Second, we already know
Oh,
the probability of A intersection B intersection C. Probability of all three intersections is
mhm.
also given to us, correct? And we can find these probabilities. So we can move from inside out to solve this question, correct?
Right. So just a quick
Yes.
thing. I think the word I was looking for was mutually exclusive. Is
Uh,
that right for the empty set one or no?
Yes, yes, you can say that clearly. So intersection of A, intersection of C, and not B is mutually exclusive. You could say that. Yes.
Oh, okay.
Good. Okay. So can we reduce the screen a bit so that we have some writing space and then we can write down the solution?
Um,
Let me clear the screen.
the only thing is that you can't see the question anymore, but
Okay. Okay. You can read it, right?
I
So
can.
yeah, perfect. So now let's, whenever we are doing three events, it's a good idea to draw three circles. Okay. So let me just draw three circles. One, two, and the third one. So these are events A, B, and C.
Yeah.
You are given that the probability of A intersection B intersection C is 0.1, correct? So
Yeah.
this probability right in the middle is 0.1. So once you know what is the intersection of all the three, that is the inside point. From there, we have to go outside. Now, let's
Right.
look into what should come here between A and B, right? So what is the probability of A intersection B?
So the probability of A was 0.25 times 0.4.
So 0.25 times 0.4, 0.4. Why do you say so?
Because in the question we are given the probability of A and the probability of B. So we can use
Independent.
that.
They are independent because A and B are independent events.
Yeah.
So just multiply and see what you get.
So 0.1.
So do you see this is, and 0.1 is already there, correct?
So you can't put anything. Yeah.
So there is nothing here, right? So it's blank. Do you see that? So what we
Yeah.
have seen is that the probability of A intersection B is actually 0.1, but that is common to all three, and therefore this part is blank for us. Now, let's calculate the probability of A intersection C. What do you get? What is the other independent event given to us? B and C. So probability of B intersection. B intersections.
So the probability of B is 0.4
Mhm.
times the probability of C, which is 0.45 because they're independent.
Correct.
And then you get 0.18.
0.18. Now, B and C is 0.18, which is this portion common to us, in which 0.1 is already there. And therefore, in this portion, I should put 0.08, correct?
0.8. Yeah.
So that is what? It is 0.1 plus 0.08 as shown here. Perfect. Now, let us find the probability between A and C. How do you figure that out? A and C.
You have to use that last statement where they say A, not B and C.
Correct. So let's look into that last statement, which is very critical. And I will make a different sketch here so that we understand the last statement clear. Okay?
Yeah.
That is the most critical part of this particular question. Now, what is the last statement? Probability of what is zero empty set?
A
Yeah.
and not B and C.
Is an empty set, right?
Empty set.
Let's try to shade. When we say A, intersection of not B. So this is A for us, right? This is A for us. This is B for us. This is C. So A intersection of not B means all this, right? A intersection not B means outside this. Do you see that?
Mm-hmm.
And I mean inside, sorry, last two are not quite correct.
Wait, it won't be the outside, would it?
Wait, not B. So A intersection of not B means within A, but not in B, right? So basically this portion. So this is A intersection of not B, correct?
Yeah.
Within A, but not B. Now we have to see what is its intersection with C.
That
with
part
C,
you shaded.
Area which is common is only this. Do you see that?
Yeah.
And this is an empty set. That means this is an empty set. Do you see that?
Oh.
So that is how you get that also an empty set. You get the idea.
I see. Yeah. So I can't. Yeah. I think it's better to do what you did and do it separate diagram and then find the spot and then put it back.
Understand. Yeah, there are different formulae by which you can expand and understand which set we are looking into, but visualize.
Yeah.
It becomes very simple, right? So you can clearly see A intersection not B is shown in orange, and intersection with C is that portion in red. And that is that small portion, which is an empty set. And with this, we get all the probabilities of combination of two or more events. Is that clear to you?
Yeah.
Now it is very simple. We can fill in the others. What is left here? Probability of A is given to you, which is 0.25. From 0.25, take away 0.1 to write down this value. So
Yeah.
0.15, correct? Probability of B is given to us as 0.4. So from 0.4, take away these two. How much do you get? 0.3 and 0.08, so you get 0.2.
0.22.
Correct. And probability of C is given to you as 0.45. Take away these two. So 45 means 5 more. Okay, so 0.2. You get your answer.
0.27. Yeah.
That becomes the Venn diagram for the given condition. Is that clear to you?
Now do we need to add it up and find the outside?
Now we have to add them up and find the outside. That is extremely important. So let's make this box, right?
Right.
And that is eta, and find out. So 1 minus all this is how much? Tell me.
So that's 0.82 everything added. 1
Hmm.
minus that is 0.018.
So what do you get?
0.18.
0.18. 0.18 is outside. Now the Venn diagram is absolutely complete, and this can be utilized to answer rest of the questions, correct?
Right. Yeah.
So if the first one here is what? We need to find probability of what? A
Oh,
interest.
sorry, can I just quickly
Yeah,
enlarge?
yeah. Enlarge.
And let me write it down. I think it says the probability. Let me just quickly write that down.
Not
The
A interest.
probability of not A and not B union C.
This is what we need.
Yeah.
Right. Okay, let's look into this. So if you zoom out, we'll figure this out. So union C. So not B union C means outside B, everything outside B.
So not B. Yeah, everything outside B.
That is first thing. And
Wait, so when it comes to questions like this, do we work like with the brackets first and then work like from right to
inside
left?
bracket first. Yeah.
Oh, okay.
So we'll work with not B union C. So we did everything, including that 0.18, and we say union C. So everything within C also. So these are also included. Do you see that?
I never get that though, because
Not B
like
is outside B.
that's not B though.
No. Union means or. That or this.
Oh,
So or
not
this. So we get 0.1 and 0.08 also because they are in C, correct?
oh, right. Okay.
And now we'll look into intersection of this group, which I've shaded in orange with not A. So not A means outside A, correct? Outside A.
Yeah.
So everything which is outside A, I'm going to mess this up, make circles there, right? So outside A means not in the green circle. So we'll add this quantity, we'll add this quantity, we'll add that quantity, and we'll add this quantity. These four quantities will be added to get you the answer for probability of not A intersection, probability of not B union C. This right A is what we are now looking into. Is that okay? So those are
But
the
then
four circled.
why is 0.22 included?
Because it is outside A. Oh, sorry. That should not be included.
Oh, okay.
Oh, sorry. You're right. Not
I was just
0.2.
checking.
Yeah.
Oh, okay.
So only three of them will be included. You're right.
Yeah.
So you have to add 0.08, 0.27, and 0.18 to get this answer. Is that clear to you?
Yeah. Now it's clear.
Other parts you
Oh,
can do. I think you've understood this part. The
yeah.
idea here is sketch a Venn diagram once again, and then figure out what should be included. Is that okay in this solution?
Right.
Rather than depending on some particular formula.
That's where I struggled because I was trying to I don't know, I was just trying to look at it and figure it out, but without drawing and sketching and shading, it's so hard. So yeah, thank you, sir. You made it clear for me.
Part C is very interesting. Can you please read the last part of this?
Yeah. So it says, state with reasons whether events not A and C are independent.
Yes. So for this, what will you say? So not A and C, let it be like. So that means are independent, means probability of not A intersection C should be equal to probability of not A times probability of C. Is that clear to you?
Yeah. So the probability of not A is everything outside plus B and C, but not including the intersection.
Not A, you can see probability of A is 0.25, right? So not A is 0.75.
Did you just do the quick way?
Yeah, probability of A is 0.25, correct? is given to you. First statement.
Oh,
Yeah.
yeah. I was gonna do the whole adding thing by
No,
looking at the diagram.
yeah,
Yeah.
great. And then probability of C is also given to you 0.45. So multiply this by 0.45. What do you get?
I get 0.3375.
Correct. Now, what you need to check from the Venn diagram is probability of not A intersection C. So now zoom in your Venn diagram and see, is it 0.3375?
So
If
when
it
you
is
say
so,
not A and C, means everything of not A is outside,
A,
and then
but intersecting with C. Open the bracket, zoom it out. I mean, zoom your written material in, and let's see probability of
a lot
not
of in and
A
out.
and
Sorry.
intersection of C. Okay, let's highlight that in a different color. Okay, let's pick a color, green. Okay, now not A but in C, right? So not A but in C means we are adding these two. Not A but in C. Do you see that? That means the
So
common
not
thing.
A, but in C.
So you can add 0.27 and 0.08.
Yeah. Okay.
What do you get?
0.27 and 0.08. Oh, 0.35.
Which is not equal to 0.3375.
Therefore, not independent.
Therefore, it is not independent. Is that clear to you?
Yeah.
That is how we could actually do this particular question. Is it absolutely clear?
Yeah, very clear.
So the last one, which is probability of not A intersection C, as you can see, is the probability of C, but not intersection of A, B, C, correct? In this
Right.
A and C. Okay. So, but easiest way is make a Venn diagram, look at all the numbers, and then from there get your result. Do you get
Yes.
it? That is
Very
how
clear.
we're going to approach. And now the next chapter on conditional probability, we are going to use these concepts to write down our answers. Okay.
Oh, okay.
So we'll
Yeah.
not really depend on formulae. We'll use them when required. Okay.
Yeah.
Let me clear the screen. Is this all clear to you?
Very clear.
Absolutely clear. Good. So let's continue. Next question. So tell me, what did you learn today?
I learned a lot. So we've carried on from last lesson, which was just kind of understanding the basics and knowing what dot A and C and union means in terms of like Venn diagrams and shading, which I was trying to get my head around because I found that really, really tricky. So now I thoroughly understand that. And then we moved on to conditional probability, which was the main thing I took away from that was like the restricted sample space that we have to have in mind, and the fact that when you change the probability or when you like use the new term that we had today, which was like probability of B given A, make sure that the restricted domain is going to change. So we saw that with the two-way frequency table and how the totals changed, and so it's very important that you be aware of that because then the probability could be wrong otherwise.
Correct.
So that was really clear. Thank you, sir.
Great. So we can end the class here. Good, you have learned. And we'll continue from here next time. Okay,
Yes,
then?
will do, sir.
All the best.
Enjoy the rest of your day.
Thank you. Bye.
Bye, sir.